In this video, we're going to look at overlapping triangles and proofs. If you notice here, I have some triangles that overlap each other. ADE and CED overlap. And here you can kind of see as a colorful triangle how they fall on top of each other there. Something important to identify with overlapping triangles is that sometimes they create reflexive sides and reflexive angles. So for example, in this triangle, you'll notice that ED is reflexive onto itself. It's the same segment because it overlaps perfectly. In this case, the two triangles ADF and CBE, they don't create a reflexive side because they don't completely share one side, but they do completely share angle B. So they create a reflexive angle. So sometimes you can have triangles that overlap that create multiple triangles, and you still have to look for those reflexive angles and sides. For example, if you look at triangle ADC and triangle BEC, they create a reflexive angle, angle C. But let's say you're looking at triangle AEB and at triangle BDA, they create a reflexive side at AB. So sometimes you have to look out for both those things. Also, vertical angles can sometimes pop up as well. So let's practice a couple proofs with overlapping triangles. If you want to try these out before I do them, pause the video and try them and check it. That's always a good idea. But I'm just going to kind of go through these. AB congruent to ED. Angle CAE. So this whole angle here is congruent to the whole angle CEA. And we're trying to prove that triangle BAE is congruent to triangle DEA. Well, you have to ask yourself, in these two triangles, do you have a reflexive side or angle? You do. AE is congruent to itself. So proof-wise, you know that you have a side, angle, and a side congruent in this triangle, so side, angle, and side in the other triangle. So if we write our proof out, we'll get our givens to go first. And I don't think any of these are going to move nicely now. But we'll get our givens here. AB is congruent to ED. Angle CAE is congruent to angle CEA. And finally, you also know that you have a reflexive side. That is that AE is congruent to AE. Make sure you're writing something under every box. Now, we don't have to change in the information to congruent statements because they're already congruent statements. So all I have to say is triangle DAE is congruent to triangle DEA by side, angle, side. So a pretty basic overlapping proof there for you. Let's look at this one. It's a little more complex. Once again, pause if you need to. AB congruent to DC. Angle F is congruent to angle E. And angle FCA is congruent to angle EBD. So you have an angle, and a part of a side. An angle, and part of a side. But notice these two triangles do have a reflexive piece in BC. So let's write our proof. Oh, that was a terrible line. Sorry about that. Let's try that again. Let's draw a line, see if we can go. Okay, I'm not getting much better, but there we go. So we have AB is congruent to DC, given. I'm going to go ahead and write next to here that BC is congruent to BC by reflexive because I'm going to need to combine these two together. We also have angle F is congruent to angle E. And finally, we have angle FCA is congruent to angle EBD. If I join AB and BC together, I get AC. And so I remember, if we remember back to our first 6 weeks, we learned something called the common segment theorem. So I know that AC will be congruent to DB by common segment theorem. Because if you have two segments that are congruent and you add the same piece to both of them, they will still be congruent. So I can join these three together, and I can say that triangle AFC, kind of like football, right, is congruent to triangle DEB. And that, of course, is by angle, angle, side congruence. Now we can take that a step further and use our corresponding parts to say that segment AF is congruent to segment DE because corresponding parts of congruent triangles are congruent. All right, let's look at one more. Once again, pause if you need to try it out, and it's always smart to try and check to see how you do. AF congruent to DE, angle F is congruent to angle E, and angle FCA is congruent to angle EBD. Well, you have a triangle here with AAS and a triangle here with AAS. So already, I know we're not trying to prove the triangles are congruent, but that's important to the step. We can prove that these two triangles are congruent without doing very much extra at all. Angle F is congruent to angle E, that's my other given. And finally, angle FCA is congruent to angle EBD. We just join those three together and we say triangle AFC is congruent to triangle DEB by angle, side, congruence. Now, because these triangles are congruent, I know that AC is congruent to DB. Granted, that's not what we're trying to prove, but it gets us closer. If I take away BC from both of them, that's a common segment, then I'm left with AB and DC. So I come back up top, and I say BC is reflexive on itself. So anytime we have reflexive or vertical angles, you put those up top. And I can join them together. Let's move that out of the way real quick. And I can say that AB is congruent to DC by a common segment theorem once again. And that's how we do these basic proofs. Look out on the homework. Some of them are a little more complex. Try to make sure your reasoning works. Thank you for watching.